right, welcome to Earth Science for one last lab video. Then you've made it. Congratulations, everybody. Couple questions. So this first one, I think back when I made this, I'd put this here on purpose because here's a good way to answer these. Now we've done a lot of like the theory on how all of this works in this lab, but we haven't really actually gotten to the nitty gritty on how these things work, like mathematically. Should you have to figure them out? So I really recommend, if you ever have to do it, that you basically set up a little table. I mean, I remember taking these tests in neuroscience and like writing exactly this in the margins next to the test. So if you write half-lives, just how many half-lives have we done? And then we'll do percentages, and you lose half of it each time. And then you do years, and some people get tempted to double it every time because some part of our brain says, well, if I'm cutting this in half every time, I'm going to double this every time. And it goes like that, then that doubles. But you don't keep doubling. You keep adding 5,700. And again, if you don't remember where that 5,700 came from, it is up here on the lab, but that's also on page 1 of your Earth Science reference tables. Right about there. All right, so let's do it. Now, this question doesn't ask us to fill this chart out, but I think is beneficial. I mean, it's going to answer the question for us, but it's also beneficial in showing us how you're going to answer ones like this and this right here, which I'm not going to help you with this directly. So that many half-lives, what percentage is left? You go from 100 to 50 to 25, then you split that in half, which it gets you to 12.5. Then you split that in half, which gets you to 6.25. Then you split that in half, which gets you to 3.125, I believe. And how long does that take? 5,700 years, another 5,700 years, another 5,700 years, another 5,700 years, which would be, we're going to test my arithmetic here, 22,800. Hopefully I'm right. It's on the internet. And then we had another 5,700 years. Making that a 5. Making that an 8. Right? Pressure's on. Hopefully I'm doing it. So this question wants to know, after 22,800 years, so we're at this line right here, how much is left? 6.25. And really, that could ask, after 4 half-lives, what percentage is left? 6.25. That could be for all of them. These years you'd have to calculate for each different isotope. But it doesn't really make it any harder. It's kind of the same thing. So after this many half-lives, this much percentage-wise is left. And then how many years did that take? Okay, let's look at some others. So if this is carbon-14, what's this? Use the reference table up at top. It tells you what it turns into. The igneous intrusion cancer. One property of potassium-40 that allows it to be useful. What's all the stuff we talked about in the last video and the one that I was talking about right before the bell rang? What is it about these isotopes and those rates that make them useful as clocks? Right? Clocks in rocks. All right, so 12 is doable if you understand how to use this. 5 is also doable if you don't understand how to use this, only now we're talking in different isotopes. So you're going to have to use your noggin, go back up to the reference table, and see what the deal is with potassium-40. But you're smart folks, you're going to figure it out. This is kind of stuck in there because we were going in a different order last year. The fossil record has shown shifts in life through time, which is evidence of evolution. After 4 half-lives, what percentage? Again, you can steal from that chart. Once you kind of figure this thing out, these are all pretty repetitive. Again, what we said here, this question number 69 is very similar to this question right here. What disintegration product is represented on the graph? Carbon-14 turns into what? You've seen that question before, not too long ago. 25%, you can do that. Okay, this is a cool one. Carbon-14, like we said, only has a half-life of about 5,700 years. I'll tell you that it's not this critter right here. That's a bad answer. That animal lived, according to my reference table, I think during the Cambrian, which is going to be a long time ago. Yep, it was a Cambrian. So it's like a 500 million year old animal. there's no way there any carbon still remaining in that. Remember, that would be where the slope gets so flat that you wouldn't be able to distinguish anymore. So which animal is recent enough to be possibly useful for carbon 14? You'll have to use that big scary page 7 and 8 of the reference table, page 8 and 9 of the reference table, excuse me, that big old thing to figure it out. 2.4 half-lives would be how many years? Oh, that's a challenging one, but you can do it. I think that's very doable. And then you're done with labs. You've done it. I think I might do, I guess I'm undecided now. Maybe I'll do another classwork quiz that has a couple of these, but I don't know, maybe the lab's good enough. What do you think? Good enough? Let us finish this here, Mr. F. I really, really, really appreciate it. I know I've said it a couple times before, but if you fought through all of these labs through YouTube here, I completely understand that it's brutal sometimes and boring sometimes. I'd much rather that we were all interacting and playing with the stuff in class, but you did a great job fighting through in these strange circumstances, and I do appreciate it. Thanks. So long. That's it.